Hey everyone, today we are going to be talking about graphs of equivalent ratios. So I have just a little check your skills section here about plotting points. So just a reminder how to plot points in the first quadrant. Remember we do X first and then Y. X is the horizontal axis. You can see the X marked right over here, and then Y is the vertical axis going up and down. So we are going to go to the right first and then go up to plot our points in quadrant 1. I'm not sure why there's lines next to each of the points, but we are going to take these ordered pairs and we're going to put them on the graph. So for point A, I am going to go to the right 2 and then up 4. 1, 2, 3, 4. And I'm going to put a point and I'm going to call that A. 0, 2 means stay at 0, so don't go left or right, and then go straight up to 2. So that's B. 5, 0 means X coordinate first, so 1, 2, 3, 4, 5, and then stay at 0. And then 3, 1 means go to the right 3, 1, 2, 3, and up 1. That's going to be point D. So we're going to be using this skill, especially the ones where you have to plot points directly on the y-axis. We will be using that quite a bit when we're graphing these ratios. I'm going to show one example, and then I'm going to have you guys actually use your online textbook to walk yourselves through the next couple, and then get to work on your homework. So in our first example here, it says tickets to the school play cost $3 each. The costs of 1, 2, and 3 tickets are shown in the table. List this information as ordered pairs. And we're going to list it as X is going to be the number of tickets and Y is going to be the cost. So for one ticket, it costs $3. And if I do an equivalent ratio, here I multiplied by 2. So I'm going to multiply this by 2 and I get 6. From 1 to 3, I multiplied by 3. So I'm going to multiply by 3 over here and I get 9. You may also see that the pattern is that it's counting by 3s. So I'm going to write these as ordered pairs. So 1, 3, 2, 6, and 3, 9. And I'm going to plot those on the graph. I'm going to label these axes just because you can see in the next graph they are labeled. Excuse me. So I've got number of tickets down here because that's listed first. And then I've got cost up along the side. I'm going to go over to 1, up to 3, over to 2, up to 6, over to 3, up to 9. So that is plotting my X, Y ordered pairs. We're just going to leave them as points on the graph because they represent the ratio of the cost of tickets and the number of tickets. So I'm going to do one more just because this one does count by 1 on both the X and the Y axis. The next one obviously goes by something a little bit different. It says Ken's Home Supply sells fencing that costs $14 for every 3 feet. Generate the set of ordered pairs for the ratio relationship between the cost Y, so here's Y, and the number of feet of fencing X. So I can see what my ordered pairs are going to look like for 3, 6, 9, and 12 feet of fencing. Now, in the very first sentence, it says Ken's Home Supply sells fencing that costs $14 for every 3 feet. So the cost here for the first one is going to be $14. I'm going to multiply by 2, and I get 28. I multiply by 3, and I get 42. And then we're going to multiply by 4, and I get 56. Now you can see on the graph over here that the bottoms are counting by 2s, but you can still see every one. So I know that this is 3, and then this over here is 9. So when I'm counting on my x-axis, and then you can see that the side goes by 5s, but my numbers aren't going to land perfectly. I don't expect them to be super accurate, but I would like them to be pretty close to accurate as to where they're supposed to be. So for 314, I'm going to put it right below 15 right there. For 628, we're going to be just below 30 in that 28 spot. 9, I'm going to go up to 42, so just past 40. And then 12, I'm going to go up to 56, which is just past 55. In both of these, you should see that the graph is very linear, so it makes a line on the graph because these are equivalent ratios. They follow the same pattern throughout. So in order for your points to be somewhat accurate when the graph is not perfectly made for them, is for them to form a line while you are working. What I'm going to have you guys do at this point is I'm going to have you try these next couple of examples. So I've got interpreting ratio relationships using the graph. So it asks you to do a couple more things, and you guys are going to use your online textbook to do so. So you're actually going to read the section in your textbook and kind of fill in, follow notes on your own today.